It's recording. All right, so here we go. We're recording the notes today, so if you missed class today because you're at a STAR test or you got prolonged STAR testing, that's why we're recording it. Normally we don't record it, but I will post the notes on D2L. So here, as a quick reminder, I know I wasn't here on Monday, but quick reminder, when we have a reaction or an equation, first thing we do, and we always do, is we're always going to balance that chemical equation. And the great thing about balancing is, once you get these coefficients, the coefficients not only tell you the amount of atoms, because you're going to have to times the coefficient by the subscript, but it also tells you the actual moles. For an example, I have 4 moles of iron over here. It also tells you if you multiply 4 times the coefficient, then I can go to the periodic table to find and look at how much it weighs, iron, Fe for an example, multiply it by 4 and get the mass. So all of that comes from the coefficient. We talked about that. Then we talked about looking at basic stoichiometry equation, which is very similar to mole conversion. Okay, the separate or the thing that's different is over here, when we did mole conversions at first, it was potassium and potassium. For this situation, this is where we're actually going to go and we're going to bridge from potassium to hydrogen for this situation. So this is where we're bridging to the next element so we can look at the next element.
You want us to keep this piece in the notes?
And I think that is one of the last pages of your notes.
But then we have on the last picture we did,
On Monday. I will post, I can post that too as an answer for D2L from Monday. So we have this, and this is where we're bridging, again, this, for an example, is where we're bridging C3H8 to CO2, making sure that we're all understanding that. We are converting moles to moles stoichiometry. Then, when we turn the page, we've already talked about converting moles to mass in grams. And again, we have to find this one commonality where we're going to convert and bridge Cl2 to NaCl. This is our mole conversions or a mole ratio that we did on page 1. Then we said, okay, well, let's go from mass to mass. We still had to go through that mole conversions, and we had to figure out, well, here's where I'm going to bridge over, and this is where I go from NH4NO3 to H2O. This is where I'm changing my elements or my compounds. Okay, let's keep going. Now we're going to be at percent yield. Okay, percent yield in our notes, and then we're going to take a look at some of our homework, and then I will extend our homework due dates now that we're all back together today. So looking at percent yield, meaning how much am I going to get? Am I going to end up with too much? Oh. I do, I say for the camera. Oh, man. All right, here we go. That was pretty good, though. I do like that. Well, remember, we're at Einstein, Gene. Baby Einstein.
I'm like baby.
Baby.
I'm not
Toddler.
Einstein.
She's ready. She's ready to go to toddler version. All right, so here we go. Percent yield. The word yield means to make or produce. Right? So the word yield means to make or produce. It says we have a couple of yield words. We have 1, 2, 3. Theoretical yield means it's going to be the actual calculated amount of product that can be produced from a given amount of reactants. This, it says here, is determined mathematically. Using stoichiometry calculations. Like what I'm trying to say over here is this is all on piece of paper and pen, and you're not doing any actual mixing, okay? You're not actually mixing it. You're using your calculator, pen, and pencil,
paper. Actual yield is the amount of product that was actually, because you went into the lab and you actually mixed the product or the reactants together, and this is what came out in your product. And then the word percent yield is the ratio of the actual yield to the theoretical yield one L. Theoretical yield expressed as a percent sign. So percent yield is, one more time to make sure we're all on the same page, actual over theoretical number multiplied by 100, so that way you can get into a percent. Pretty easy cheesy. It's on the formula chart, so I promise you it's in there. We actually have done something very similar to this. Percent yield, we have. We have.
Or did we do percent composition, right?
Is it the percent composition?
It was like the decimal times 100.
Over the number?
Yeah, it was percent composition.
So we've done it very similar. It's a really easy, cheesy one here. So let's look at the first one. Oh no, this one's an easy one. It says in this situation, in the lab, you burn 3.2 grams of magnesium. Okay, alrighty. And you produce 4.8 grams of magnesium oxide, according to the given reaction. Like you physically went into the lab. This is you going in the lab. Your calculations showed that you should, whoa, I'm gonna come over here. Calculations showed that you should make 5.3 grams of magnesium oxide. What does that mean, calculations? Theoretical versus actual. So I'm gonna come over here and I'm gonna put actual is in the lab, calculator is theoretical.
Will it always say like in the lab or something like that?
Or performed, or your experiment
Like telling you that you actually did
that you actually did it, yep. So in this situation, I can see what I did do and what I theoretically calculated. It says here, this is what you should have got. What is your percent yield? Okay, well then my percent yield, which is this equation right here, actual over theoretical, my actual was 4.8 in the lab. Theoretically, 5.3 is what I should have got. Multiply by 100 equals, we're picking on Peyton, but the next person we're going to pick on is Zoe. Peyton, what do you got? You better get something.
90.57%. So you don't have to like balance or anything?
No. Mm-mm.
He just told us we always had to balance our equations, and now we don't have to balance our equations.
We're not even, to be honest, we don't even need that equation.
You just need the word.
I just needed the words. I don't even need that equation. That equation was just there for extra junk. Sorry. There we go. All right, let's try it again. Question number 2. Let me screw it up. Using the picture to the right, after performing the following setup, okay, so if you performed it, that means that you did it, alrighty? After performing the following setup, you collected 150 grams of, so after performing, I'm going to call this right here actual, because you did it. What is your percent yield for this experiment? Oh, they sure did. So let me scoot in so that way we can look at this one a little bit closer. Now, what are we looking at? We are looking at CaCO3, and they gave us, and we're looking at, is it the reactants or products? Yield. What's the word yield mean? Products. It looks at products or what you produced. So if this is on the product side, this is what I actually did. theoretically, pen and paper, what did they theoretically, so let's go ahead and I'm going to write, oops, I meant to do that in orange. Theoretical is, what's that number, 152? There we go. Let's go ahead and do our math. This is Zoe's number. 157 over 152 times 100 equals,
Wait, is it supposed to be more than
It says
100?
152
Mhm.
Is it supposed to be more than 100?
calcium carbonate.
It says, because this is calcium carbonate is what we're looking at, and so we're just looking at the calcium carbonate, we're not looking at the zinc. You said they only gave us one number. Ayla, you are so correct. The cool thing is, that's the only number we needed, because we're looking for calcium
So
carbonate.
the picture is what they should have got instead of what they did get?
Yes, yes, yes. This is,
I'll write that in here. Theoretical is should have got.
So like the picture is,
The,
yes.
yep. And the actual is what you did get. So actual versus theoretical. What did you really get versus what you should have got? Now, Zoe just said something real quick, and I don't know if you actually heard her. Zoe said, "Psh, would this be over 100? Mathematically, that doesn't sound correct. Like, I hate people who say, oh, give 110%. You can't give 110%. There's no mathematical way that that's possible. Zoe just got a number. Zoe, what did you get for your number? 103.9%. That is the correct number. And could it be over 100? It could be. Why, Miss Munson? Well, what if there was some contamination and you actually mixed some more stuff in this product? What if you used a dirty container at the end and you put it in a dirty container that had extra stuff under the bottom of it, and when you weighed it, it came out to be a bigger number than what it should have been? So things could happen, you know, and that's how you got a bigger number. I agree that you shouldn't have more than 100. Let's go again. Second, number 2 example, I guess. During a lab experiment, so I'm going to,
4.8 is under theoretical.
well, if it's during the lab experiment, that means that you're doing it.
Okay.
Actual. So I'm going to put a little arrow and put actual. Because in the lab experiment, this is what you're doing right here. 24.8 grams of calcium carbonate is decomposed and 13.1 grams of calcium oxide, CaO, is produced. Okay? Alrighty. Number 1, what is the actual yield for the calcium oxide? And then number 2, what's the theoretical yield? And number 3, or letter C, what's the percent yield of the calcium oxide? Okay?
13.1 the actual instead.
Say it again.
13.1 is actual instead because it produced. Because we started with the 24.8 at first, so it's not.
Oh, whoa.
So, oh, that's what you were saying. Okay, I see what you're saying. So during a lab experiment, let me write it over here. It's just so that way my brain can keep up with this. 24.8 grams of calcium carbonate is right here. Okay? And then it's going to decompose to 13.1 grams of calcium oxide. So calcium oxide, 13.1 grams. And then it says over here, then we have CO2. Well, they didn't give us anything regarding CO2. Thank goodness they're not actually asking for any CO2 either. Thank goodness. Question says, what is the actual yield? What is the theoretical yield? But wait a minute. It is CaO, CaO. They're not even looking at this number, CaO3. Does that make sense? Okay, I just want to make sure. So the 24.8
CO3, but this is CaO, CaO, CaO. So even though I underlined this saying during the lab experiment, this is what they did, and it decomposed to this and this, they're asking us not even for this information.
So would it go on the bottom?
So, first question is, they're asking us how much of the CaO? Look at the numbers. How much of the CaO? 13.1. Okay. And why is it 13.1? Did you see over here? I agree. It decomposed into this and it produced that. But do you see how I said actual?
So you subtract 13.1 from 24.8.
Mmm.
The rest of the yield.
Mmm.
So the theoretical number.
Mmm. Okay, but wait a minute. I like this thinking. Okay, let me go ahead and rephrase this. 24.8 is what I'm starting off with. And if I use 13.1, then whatever's left over is a CO2 or the carbon dioxide. I agree with Ayla 100%. The problem, though, is that they want to know what the theoretical yield for CaO is. They don't even care about the CO2. Does that make sense? So even though what she said is great info, they're not even looking at the CO2. Look, I'm going to cover up the CO2 right here. So I covered it up. But let me go back. Go back to the top of your page. What does theoretical mean? You're going to use a what? Calculator. And they didn't give me theoretical here. That means that I'm going to use my calculator here.
Is that what you need the periodic table for?
Yes. Yes. We're gonna do our own theoretical. We're gonna do it ourselves. And we're gonna do this from our stoichiometry that we learned on the previous page. So let's go ahead and do this. It may not be fun, but we're gonna get it done. Oh, that rhymes. Okay. How much? We're looking at, what number are we looking at? We're looking at, I'm looking for this, is my question, theoretically. Do I know it over here? No, I don't know it. I'm going to put a question mark. I don't know this number. I'm not looking for this. I'm going to put a little X too, because I don't know it, number one, and I'm not even looking for it, number two. This I know is going to be actual. Do I know any theoretical? At this moment, any theoretical? No. But I do know that I started off with, and I'm going to go back to what Ayla said, I started off with 24.8 grams is what I'm starting with. That information I do know is accurate. Okay? So I'm going to start off with 24.8 grams of CaCO3. If I have grams, I got to put grams at the bottom, just like algebra class, CaCO3. I've got, here we go. Oh, Ca is a metal, calcium, C and O. Oxygen is right here. We count that as 16. Carbon is right here, 12. I'm just going to count it as a 12. And then calcium is right here. I'm just going to count it as a 40.
Wait, aren't we finding CaO?
Oh, CaO. Good call. How many CAs do I have?
Yeah, one. Or two.
Oh, whoa, 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 whoa. Hold up. Zoe threw me off. Hold on, I'm going to pick on Zoe really quick. Zoe, what did you say I'm looking for?
CaO.
I agree, but I'm going to use this number, which has CaCO. Oh, so I can't get rid of this carbon. I'm gonna put carbon back over here. So I'm looking for the molar mass of that carbon right here. I'm gonna bridge like I did with the molar mass, like I did on the previous pages of notes. Does that make sense? Okay.
7 grams.
I got 100.09. Okay.
I just added them.
I might be 3 oxygens. That's why. So once I got 100.9, and from this right here, I know that the molar mass of anything equals 1 mole. So I'm going to say this equals 1 mole of CaCO3. Hopefully we all agree with that part.
So this is a mass to mass equation.
We are, yes. Yes.
From mass to moles and then
Back to mass, yes. Yes. So now, if I have moles over here, I've got to put moles down here. And what am I using? This is where I'm going to bridge
Blank moles of CaCO3.
to
Two.
now the CaO. But wait a minute, is that balanced?
But it would have no idea.
It is balanced. 1, 1, 1. So in this situation, using the molar mass ratio of this to this, 1 mole from this balanced equation of CaCO3 equals, and I'm just going to box this in because this is where I'm bridging to the other 1 mole of CaO. Okay, this is very evil, but this is in grams, and I need grams. So I'm not okay with moles. We gotta go back to grams again. So let's go ahead and do that. If we have moles at the top, I have to put moles at the bottom of CaO. I'm going to come over here and I'm going to say Ca is 40, O is 16, 56. Sounds good to me. That's what I got. Grams of CaO. Now I'm done with my stoichiometry. And this is what I mean by theoretical. We said during the lab, that's actual. They didn't give me a theoretical, which means pen and paper and calculator, so I did it myself.
Do you actually have, like, multiply and divide and all that? Did you divide and
Yes. Double check my answer, but I got 13.9 grams. Okay, that's what I got. 13.9 grams. I mean, I might be a hair off if I use 56.02 or something, but 13.9 grams.
supposed to multiply the top and divide by the bottom?
Mm-hmm. Yes, ma'am. So 24.8
This is really
times 56. I told y'all this is like the ultimate unit of everything combined. This is divided by 100.09. I got 13.1. Now that I have an actual and a theoretical, I can find the percent yield. And let's go ahead and do that, which is going to be, my equation says actual over theoretical, or 13.1 over 13.9 times 100 is a 94.24%. That's a pretty good number. And I do agree with Peyton earlier that getting 100% of anything is almost impossible. I mean, you put $10 of gallons, you put $10 of gasoline into your car, you're not going to drive $10 worth. You might drive around $8 worth because just turning on the car uses up gasoline, okay? So you don't always use 100% of the gasoline that you put in, okay? Example number 3, or number 4.
Not to fill up, just to put gas in.
Here we go. Let's try it again. During a lab experiment, oh man, okay, during a lab experiment, I'm gonna come over here and I'm gonna write the word actual. okay? 1.87 grams of aluminum, okay, reacts with, plus copper 2 sulfate. And 4.65 grams of copper is produced. Yields 4.65 grams of copper is produced. What is the percent yield? Okay, well that means that I need actual and theoretical. And when I go back and read this again, during the lab means that's actual. I didn't do anything that says theoretical over here. So it looks like I'm gonna have to use my pen and paper calculator to come up with the theoretical. But I do have the actual. Now before I start, now I'm gonna go back over here and say, yes, we do need to double check to make sure it is balanced. Don't trust them, and it is balanced at this moment. 2, 3, 1, and 3 is a balanced equation. Okay, so I am balanced. And I'm gonna go ahead and put right here, first check if balanced. First check to make sure that it's balanced. Okay, we need, and if this helps you out, I'm gonna write it over here. We need the actual, we need the theoretical. That way we can calculate the percent yield. Now they gave us a number, but let's see if it's the correct numbers. We're looking for, what is the percent yield? What am I looking at the percent yield of? Copper. Because percent yield, or yield, means your product. Does that make sense? And they did give us this actual product of copper that was done. So in this situation, I know that my actual is 4.65 grams of copper. Oops, Cu. Okay? Now I need theoretical. That's pen and pencil paper with your calculator. So in this situation, I need to find the theoretical of copper. Now, they gave me the actual of copper, and they gave me this number. Do you agree with that? Those are the two numbers that they gave us. Can I use 4.65? No, because it's my actual number. I can't use that because I'm actually going to use the percent yield of that. I'm going to have to go with this other number, which is 1.87 grams of aluminum. That's the number I have to use. I cannot use the other number that's in my equation. Now, if I have grams of aluminum at the top, I have to have grams of aluminum at the bottom. Periodic table, aluminum is in group, what, 14, 13? 26.98. 26.98. And from this chart, the molar mass equals 1 mole of aluminum. Now, I'm not looking for aluminum. I'm looking for copper. This is where I get the chance to go over here and do the molar mass conversion. And I can say, using the coefficient of 2 moles of aluminum, that equals, look at this, 3 moles of copper. So I'm going to go ahead and just box this in, because this is the location that I'm able to bridge from the aluminum to the copper. Okay, now I can come over here, and I know that using the periodic table, 1 mole of copper, Cu, 63 point, let's call it 55. 63.55. Roxanne, do you have your calculator out?
Yes.
Okay, only because other people have done, we're giving you a chance. Thank you. Okay, multiply, 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 and then divide. Somebody wants to double check Braxton? Just in case. Okay. If you can give me the top number separate from the bottom number.
Top number, I got
165.5. Bottom number? 50 something?
53.9.
53.96. Now divide. 53 can go 6.67. Sounds good. Oh, of what? 07 grams of Cu. And I'm going to put right here, this is theoretical, because we just did this with the calculator. 6.607 grams of Cu. I don't know. I thought,
It is 350.
Oh, 356.
oh,
356.
I'm sorry. I might have done a, what do you call it?
Yeah, I also got that.
I might have done a dyslexic move. 356.
I actually, no, I said it because I saw the numbers and I was like, oh, that looks like the amount of days in a year. And then-
Oh, 365. Oh, yeah,
And
yeah.
then that's
that
what I
was-
said, that's what I
And
was
then-
saying
The
out
answer's
loud.
still the same.
Squirrel.
The answer's still the same.
What do you mean, how
No,
many?
it's not. I put 356.5
Point five divided by
divided by 53.96 and got 6.607.
6.6 is, yeah.
That's
He,
what the answer-
he said it wrong, but he typed it in right. Yeah, that's what it was. He just said it wrong.
So now that we have our two numbers over here, we can go ahead and divide these numbers and .65 divided by 6.607 multiplied by 100. Leo, what'd you get? Yes, sir. 70.37.
70.37.
Is that what y'all got? That's what you got? Okay, two people got it. Okay,
I put
Two.
1.65.
well, hold on. We got two people that got the same number. That's why we check each other.
What did you get?
70.05.
Yep. What did, Zoe's checking the number.
Yeah,
So-
I put
there you go, yeah.
73.
Rounded a little different. Yeah.
I got 70.5.
Woo, 70.50? I'm not sure. That's a little bit way off. I know that sounds like it's not, but in chemistry, when we're talking about like creating drugs or getting the person the right amount of drugs so they don't die on us, it kind of could be.
I got 70.38.
Somewheres.
Yeah.
38.35, we're good. And the reason why, Leo, because I don't want to be like, man, Miss Munson's always picking on Leo.
No, I agree.
No. This is the reason why. Some of us got .38, some of us got .35. But wait a minute, the difference was where? Not in the tenths, but in the hundredths place. So when we get to the hundredths place, when we're talking about medication, then in that place, in that situation, it's not too bad. But when we're talking about me and Leo, if I got 30 something also. But, because I did it last year.
7.9, so go to an 8, right?
Yes. But .3 versus .5 are 2/10 off. Believe it or not, regarding medication on a person who's sick or ill, that would, for those of us wanting to go into that kind of chemistry medical field, it could be damaging. Or it could not help the person.
Overdose by 0.5%.
You know, right? I know it sounds crazy, but it's true. So, it sounds weird. Okay, next question. Limiting in excess. Is this what our homework is covering? Homework number 3 that we didn't do.
I think we had something about like name movement and
Okay,
I think the back of the page was.
the back of the page. Oh, stoichiometry, homework number 3. Homework number 3. Homework number 3. Gotcha.
3 pages?
Unless I'm wrong. You only got 2? Oh, okay. Oh, look, I'll rip that off. I'm going to believe Zoe. She better not be lying.
It's just a front and back page.
Okay, just the front and back, okay. I don't know where that came from. I don't know.
printed homework 4 under homework 3, because homework 4 is also front and back.
Front and back. Okay, maybe that's what it was. Okay, homework 3, percent yield. Should you be fired as a chemist? Wow, that's intense. Are you coming in? You come in, sit down. Yeah, should you be fired? Wow, okay.
I should be fired.
Oh my gosh. Okay. Next one over here. Balance it. Which reactants are the limiting? Okay, so it does ask regarding the limiting. Okay. If you're both taking it, then y'all can sit on 2 separate sides of the room. Here we go. First step. While they are coming in, let's go ahead and I agree balance, but we can do that one later. Balance. Let me get, here we go.
Whoa.
Well, I'm going to let you write this in.
I think.
I'm going to let you write this in while I get their stuff. You need a pen or a pencil. You need your graphing calculator out, right? You're going to need, let's see what else.
Formula chart, test, and protractor?
You know what? Since we're recording, y'all are so nice to each other. We're always nice to each other. No, we're not. Your wife
I
is
think
our
this is the
little-
Brooke Road thing, so you guys
Being mean is when you're nice, okay? Products. Does that say you? How much product you use? Yeah, you can
Do you think he'll actually watch it? You think he'll put it on mute?
He is not watching this.
No, no, no. It's not live.
keep it on pause.
And we love our students who are missing from today. We miss you.
There's no shot for watching.
No one, Miss Munson, no one's going to believe that.
Hide like a secret question at the end, and then
Give
ask
him,
him what the
extra
question
credit,
was.
Like halfway through.
I don't ever watch a lot of the
Just
online stuff I have
just
to
feel like I'm
classes. Like I just put it on mute and let it play.
5 extra points.
But don't tell him that there is. Like don't say there's a secret emoji. Just be. I'm not just in the next class.
Leah, what did you-
Can anyone tell me what the emoji was?
Can anyone tell me? No, that's vicious.
You would know if he watches the videos or not, though.
That is true, but